Hey guys, I'm so glad you're here. I could really use some help trying to finish this little wooden sculpture I'm making. So if you take a look at it, I've just got a triangle on top of a rectangle, and I thought it would look nice and decorative. I need to get this lag screw to go all the way through and down into this piece, right? But it's pretty tough. I've been using my ratchet in the socket here to turn, to grab on, right? And just squeeze there. And it's getting pretty tough. I'm getting kind of tired. So what I want to talk to you about in the midst of this is the concept of inverse variation, right? What I'm doing here is applying a force at a certain distance, right? So we're looking at that distance. I'm applying a force at a certain distance, and it's creating a torque. And it's the torque that's causing this to move, right? So that's a constant. The torque required to get this thing to move is a constant. What I'm having to do is try and apply a force here at a certain distance to create that torque. So torque is essentially the product of force and distance. But the torque is what's constant. So that's what I want to point out here. And I'm just having a really hard time generating the force to cause it to move at that distance. So what I'm going to do, I'm going to introduce a cheater bar. So, what role is this thing going to play? Well, if you understand that the torque is created by the force times the distance, otherwise known as a moment here if you guys go on engineering, then I need to be able to multiply my force somehow or get my torque up somehow. So my force. So what's going to happen here? I'm going to increase my force with this cheater bar. How? Technically, I said that wrong, didn't I? I'm actually not going to increase my force. I'm going to keep the same torque, but I'm going to make it a whole lot easier because now, if I increase the distance, then the force I have to use to turn is going to go way down, right? Look how easy that is. I'm barely turning this thing. You hear it? So what just happened? I increased the distance of my force application, and the actual amount of force went down. Let me say that again. I increased the distance, and the force required went down to produce the constant torque. So why do I keep emphasizing one went up and the other went down? Well, that is what happens in inverse variation, right? My distance went up for the application and my force therefore went down so that my torque would remain constant. How is this different than direct variation? Well, direct variation required both variables to go up, right? You had a constant there, but both variables went up. So in another case, it could both go down. But direct variation is going to have your variables that behave the same way. Whereas inverse, one's going to go up, the other has to go down to produce that constant. So let's take a look at what that looks like on paper. We'll go over here to my writing station, take a look at some of the things I've gotten written down. So, what we're going to talk about first is the idea of torque, force, and distance. So right now, if I take a look at this equation, torque is my constant, and that is equal to force times distance. Okay? Force times distance. And so what's happening here, a constant torque is found. If I increase my force, then I can decrease the distance that I apply it at, and that'll maintain the same product or constant torque. Or if I want to keep the same constant torque, let's say that was 100 Newton meters. Okay, it's still 100 Newton meters. What's going to happen here? Let's say I'm applying the 50 Newton force at a distance of 2 meters, right? 50 times 2. Can you guys see that? 50 times 2, right? So now, what if I increase my distance to 4 meters, right? So now if I decide to use a bar that's longer, I can actually decrease the force required here. So 25 newtons times 4 meters, that's going to give me the same torque. So what just happened? The force went up, the distance goes down. The the force goes down, the distance will go up. That is inverse variation, right? So the last thing I want to clarify here is you're looking at this and you're thinking, oh, that looks kind of like direct variation. Look at the structure, right? Here's a reminder. Direct variation is y equals kx. But here's how we're going to tell the difference. Look at where the constant is in direct variation. Look at where the constant is in inverse variation. So f and d were my variables. So taking a look at that, right, if we have t, let me show you what I started with here. T equals f times d, and that's my constant. Well, what if I want to solve for f in this case, right? So I would divide both sides by d, and I'd end up with force is equal to torque, which is the constant, divided by distance. This is going to kind of remind us and kind of be in your mind, I hope, if you look at this enough, of what inverse variation looks like. These are both equivalent forms. But the last thing to point out again is look at where the constant is. That constant of variation, identifying the role that that plays is what's so important. So, direct variation, if x goes up, so does y. With inverse variation, if x goes up, y goes down. And so we can see that in table form as well. If we take a look at one last little piece here, right? We have, let's say we had torque was equal to force times distance, and that's my constant. So what I'm going to do, I'm going to make a little table. And let's say we were looking for 100 Newton meter torque, okay? So just to clarify here, we had to apply 50 newtons, right? That's in newtons, and this is going to be in meters, at 2 meters to produce 100, right? But let's cut that in half. 25, so that was times 1/2. So the opposite is going to happen here. I'm going to multiply by 2 to get 4, so that my product is still 100 Newton meters. That's the torque I'm looking for, right? And we could do another one. We could say, okay, what if my force was only 10 newtons? Then my distance is going to have to be 10 meters. Again, it's still going to give me the same constant torque. So just to kind of give you a little harken back to what I did in the previous video, how do we go from 50 to 10? We're going to multiply by 1/5. So how do we go from 2 to 10? We're going to multiply by the opposite of that, 5. This is inverse variation.